Let's see few numericals on the Pelton wheel. We have already seen different formulas, the formula force exerted for the work done, and we've calculated the efficiencies. We've seen different types of efficiencies. Now let's see few numericals. So here's the question. I'll read out the question once. A Pelton wheel having semicircular buckets. See the why they've given semicircular buckets is because they want to tell you that the angle at which the relative velocity at the outlet it goes directly opposite. The angle of deflection is zero. It means the angle of deflection is zero. So that is what it means. The angle of deflection is zero here in this case. It is having a diameter of 1 meter. The diameter of the bucket is 1 meter. So the pressure at the nozzle when it is closed is 15 bars. The pressure is given so that we can calculate the available head. Discharge when the nozzle is open is 3.5 meters cube per minute. The discharge is given. If the speed is 600 rpm, find the power developed by the wheel. The power that is developed by the wheel, that is we have to find. And the hydraulic efficiency is also we have to find. CV, that is a coefficient of velocity, is 0.98, and the overall efficiency given is 0.85. So the power developed has to be found. Also the hydraulic efficiency has to be found. So let's see what the data that is given. Let's write down the data. Diameter is 1 meter. The pressure at the nozzle end is given as 15 bars. 15 bar is nothing but 15 into 10 raised to 5 Pascal. So bar is not the SI unit of pressure, so you need to convert in terms of Pascal. So 1 bar is 10 raised to 5 Pascal. So multiply by 10 raised to 5 will give you pressure in terms of Pascals. The discharge is also given as 3.5 meters cube per minute. The RPM is given as 600. So using the pressure we can calculate the available head. So pressure divided by rho g will give you the head, that is 15 into 10 raised to 5 divided by 1000 into 9.81, which comes out to 150 meters. Once you get the head, you can calculate the velocity. So 2gh gives you the theoretical velocity, and if you multiply the theoretical velocity with CV, you will get the actual velocity. That is why the CV value is given. So V1 is the absolute velocity of the jet at the inlet, which comes out to 53.16. Now let's calculate u, that is the velocity of the bucket. So the formula for u is pi d n by 60. It's a very basic formula that we've been studying in other subjects as well. Diameter is given as 1 meter, so 1. The RPM is also given, which is 600 RPM divided by 60. So once you substitute the values here, you get the value of u as 31.4. Now since we've got the value of V1 and U, let's calculate hydraulic efficiency, because the hydraulic efficiency formula we already know, we've already derived it earlier. So once you substitute the values of V1, U and phi, you get the hydraulic efficiency as 0.754, which is nothing but 75.4%. So we've calculated the first part, that is the hydraulic efficiency. And the question is why I have taken phi as 0. Phi is nothing but the angle of deflection. So I can explain you through a diagram this, why the deflection phi is 0. The buckets are of semicircular shape, which means the water comes in and goes out in the exactly opposite direction. It doesn't go out at a particular angle. So as you can see here, the inlet is horizontal towards right and the outlet is horizontal towards left. So the angle of deflection is 0 here. So I've taken phi as 0. Now the next thing that we have to find is the power developed. So for that case we have to use the other thing that is given, that is the overall efficiency is given. The formula of overall efficiency is the power output upon the work input. So overall efficiency is nothing but the power output upon the water power, that is the power output has to be found. The overall efficiency is already given, which overall efficiency is 85%, which is nothing but 0.85. The water power is nothing but rho g QH. So the overall efficiency is 0.85. The water power is nothing but rho g QH. And once you multiply power with rho g QH, you will multiply overall efficiency with rho g QH, you get the power developed. Since the fluid is water, we know that the F density is 1000. The discharge is given in terms of meter cube per minute, so we have to convert that in meter cube per second. So you will get 3.5 divided by 60 meter cube per second into H. We've already calculated H, which is 150, and once you multiply these things you get the power developed, which comes out to 72.96 kilowatt. This is the output power that will be developed. So that was all about this numerical. Let's go on to the next question now. So I'll read out the question once. A hydroelectric power plant is having Pelton wheel working under a head of 600 meters and produces 16,000 kilowatt power at 430 rpm. So if the efficiency of the wheel is 90%, so the efficiency of wheel is nothing but the hydraulic efficiency. So I mean the efficiency of the wheel is the efficiency of the whole turbine. So that, I'm sorry, it's the overall efficiency. So the efficiency of the wheel is 90%, which is the overall efficiency given. So we have to find the discharge and the diameter of the nozzle, also the diameter of the wheel. So these three things has to be found, and the data is given. The head is given, the power developed is given, the RPM is given, also the speed ratio is given, the coefficient of velocity is given. So using these things, we can easily calculate whatever we need. So let's start solving this question. So let's first of all write the given data. So the diameter of nozzle I've taken a small d, and the diameter of the wheel I've taken as capital D. So these things are given and these things has to be found. So let's start solving. First of all, since the head is given, we can calculate the velocity at the inlet. So the velocity at the inlet is Cv times under 2gh. So the given head is 600 meters. So once you multiply these values, you get the value of V1. Now we've got V1. Next is using the specific, the speed ratio, the value of speed ratio, you can get the value of U. So once you multiply these two numbers, you get velocity of U as 48.91. Now since we know the value of U, we can get the diameter of the wheel, which is U is pi d n by 60, n is already given. So once you simplify this equation, the diameter comes out to 2.17. Now we've got the diameter. The remaining things the diameter of the wheel is we've already found. Next is the diameter of the nozzle and the discharge, that is we have to find. So for finding the discharge, we can use the formula of overall efficiency. So overall efficiency is nothing but power developed divided by the water power. And the value of overall efficiency is given, which is 90%. So in terms of fraction, you can write 0.9. The power developed is given as 16,000 kilowatt. So which is nothing but 16,000 into 10 raised to 3 watts divided by rho, which is 1000 for water, G, which is 9.81 universal value, and head is already given. So after you simplify this equation, you get the value of discharge. You have to calculate the discharge also. Now, since you know the discharge, the diameter of the nozzle can be easily found. So Q is area times velocity. The discharge happens through nozzle, so the area has to be of the nozzle. And once you write the formula of area in terms of diameter, the diameter has to be the diameter of the nozzle. So once you simplify this equation, you get the diameter of the nozzle as 0.19. So the diameter of the nozzle is 0.19 meters. So that was all about this numerical. Let's move on to the next question of Pelton wheel now. So let's see next question on the same concept of Pelton wheel. So the question is, two jets strikes the bucket of a Pelton wheel which is having a shaft power of 15,500 kilowatt. The diameter of the each jet is 200 mm. If the net available head on the turbine is 400 meters, find overall efficiency of the turbine. So let's write the given data first of all. So first of all, let's calculate the area of the jet, cross-section area of the jet. Since the diameter is given, the area can be found out easily. Since we have found the area, now let's calculate the velocity. Once we get the velocity, the area into velocity, we can give you discharge. The value of CV is given as 1. So once you solve this into your calculator, you get the value of velocity as 88.59 meters per second. So we've got the value of V, that is the velocity at the inlet, that is V1. We've got the area. So the next thing is to calculate the discharge. So the discharge is 2.7. It says this is the discharge that we get through a single jet. Read the question carefully. There are two jets strike the bucket. So this is the discharge that you get from a single jet. So the net total discharge is 2 times of this value, because this is a discharge from a single jet. There are two jets like this, so you have to multiply it by 2. So this is the Q total, the total discharge we have got. Now we have to calculate the value of overall efficiency. So for overall efficiency, you should know the power developed and the power input. So let's calculate the. So we've got the power output. The power output is already given as 15,500 kilowatts. And the water power is nothing but rho GQH. And we know all the values. The rho is 1000, G is 9.81, Q we have already calculated 5.56, H is given in the question. So once you substitute all these values of rho, G, Q, H, you get the value of overall efficiency. So the value that you get after you simplify it is 0.7104, which is nothing but in terms of percentage 71.04%. So this is the value of overall efficiency that the question was asking about. The overall efficiency we've already calculated. So that's all about the question. Let's see the next question now. So I will read out the question. Two jets strike the bucket of a Pelton wheel which develops 15,000 kilowatt power. The total discharge is 6 meters cube per second. If the net head on the turbine is 350 meters, find the overall efficiency of the turbine. So the given data, let's write the given data first. Now it's a very simple question. You just need to use the formula of overall efficiency and you'll get the answer. So the efficiency comes out to 72.8%.